So we have the position vector of A. So position vector of A is A, position vector of B is B, and the position vector of C is C. So in question number A, what we have is the position vector of C is equals to A plus B. So let's put the value of A, which is 2I plus 2J plus K, plus B is I plus J minus 4K. That means 2 plus 1 is 3I, plus 2J plus J is 3J, and K minus 4 is minus 3K. So that is the position vector of C. Question number B, OACB. So this is going to be OACB. You have to be careful. It is not OABC. It is OACB. So in order to prove something is a rectangle, each of the angle has to be 90 degree. That's one way of proving it. Another way of proving it is a rectangle is a parallelogram where the angles are all 90 degree. So that means if you can prove that this is a parallelogram, all you have to do is prove one angle is 90 degree. That means the rest would be 90 degree by default. So how do you prove something is a parallelogram? In case of a parallelogram, the opposite sides are exactly the same. That means they have the same direction, they're parallel, and they're also equal. So here we have OA. Write down OA. So OA is given. Let me write down the column vector format. It's faster. 2, 2, 1. This is OA. Now let's find BC. So BC is OC minus OB by position vector rule. So OC we just found out. So 3, 3 minus 3. And OB is given IJ minus 4. 1, 1 minus 4. Let's see whether we get the same vector. 3 minus 1 is 2. 3 minus 1 is 2. And 4 minus 3 is 1. It is exactly the same. That means, therefore, OA line is exactly equal to the line BC, and the scalar is also the same. So they are parallel and they are equal. So the first pair works. Then this one, OB and AC. And so OB is IJ minus 4. 1, 1 minus 4. And then we have AC. AC is going to be OC minus OA. So OC is 3, 3 minus 3. And OA is 2, 2, 1. It turns out to be 3 minus 2, 1. 3 minus 2, 1. And minus 3 minus 1 is minus 4. Again, it is exactly the same. So OB is equals to AC. So since the opposite sides are equal and parallel to each other, we can write, hence OACB is a parallelogram. Now to prove that it's a rectangle, we just have to prove that one 90 degrees present. That's it. We don't have to worry about the other. By the definition of parallelogram, the others would automatically be 90 degree, because if this is 90 degree in parallelogram, the opposite angles are equal. So if this is 90, this has to be 90. And then we have the supplementary rule. Parallel lines together makes 90 degrees. So if this is 90, this has to be 90. By default, every angle would be 90. So let's prove OA and OB, they make 90 degrees. So remember, if they make 90 degree, the dot product has to be 0. For OA dot OB, so OA is 2I 2J plus K, dot OB is IJ minus 4. So let's see whether the dot product is 0 or not. 2 into 1 is 2, plus 2 into 1 is 2, plus 1 into minus 4 is minus 4. That means 4 minus 4 equals to 0. That means they are perpendicular. So you write, since OA and OB are perpendicular, OACB is a rectangle. That's it. All you have to do, that a parallelogram has one angle 90 degree, then every angle would be 90 degree, and thus it would be a rectangle. Now question number C. Question number C says you have to find the midpoint of the rectangle. The midpoint is basically the midpoint of the diagonal where the two diagonals intersect. That is going to be the same. So it doesn't matter which one you take. You can take either OC or you can take AB. So it is easier to take the midpoint of OC. So coordinates of OD is going to be midpoint of OC. So it is going to be the coordinates of C divided by 2, because this is 0, 0, 0 and C is 3, 3 minus 3. Just add them and divide by 2. So this is going to be 3 by 2 plus 3 by 2 minus 3 by 2. It means 0 plus 3 by 2, 0 plus 3 by 2 divided by 0 minus 3 by 2. So that's it. That's the coordinates of D, and the position vector is going to be, this is D. So the position vector is going to be 3 by 2 I plus 3 by 2 J minus 3 by 2 K. So that's the position vector of D. Now we have to find the angle of ADC. So ADC, this is the angle we have to find. So we know the midpoint. So this is D. So we have to find this angle ADC. This is the angle we're looking for. Now this is important to remember. In order to find ADC, you have to remember an important rule for finding the angle. So this is how it works. When you're finding the angle, you have to remember the angle is between AD and CD. So the angle ADC has to be like this. It is important to remember the arrow has to go towards the point, or it could also be DA or DC. It has to go outside from the point where the angle is being formed. It cannot be like AD and DC. This is very, very important. So please remember how this is working. So for finding the angle, so cos theta would be AD dot DC divided by modulus of AD modulus of DC. That's the rule, direction vector. So let's find AD first. So AD equals to OD minus OA. So OD is, we know it is 3 by 2, 3 by 2 minus 3 by 2 minus OA is 2, 2, 1. So if we subtract, 3 by 2 is 1.5. 1.5 minus 2 is minus half. 1.5 minus 2 is again minus half. Minus 1.5 minus 1 is minus 2.5. That is minus 5 by 2. So that's what AD is. Now we have to find DC. So DC is OC minus OD. So OC we already found. OC is 3, 3 minus 3, and OD is 3 by 2, 3 by 2 minus 3 by 2. So this is going to be 3 minus 1.5 is 1.5. So this is 3 by 2. 3 minus 1.5, 3 by 2 means 1.5 is also 1.5. So this is also 3 by 2. Minus 3 plus 1.5, this is going to be minus 3 by 2, minus 1.5. So this is how it works. So we found AD and DC. Now we have to find the angle. So let me do the question over here. Okay. So cos AD is minus 0.5. Let me use decimals. It's easier to write. Minus 0.5 minus 5 by 2 is minus 2.5. Dot. DC is 3 by 2, 1.5, 3 by 2, 1.5, minus 3 by 2, minus 1.5, divided by square root of minus 0.5 whole square plus minus 0.5 whole square plus minus 2.5 whole square. Square root of 1.5 whole square plus 1.5 whole square plus minus 1.5 whole square. So this is how it's working. So 1.5 minus 1.5 into, let me use the calculator for this one. We can do this quicker. So 0.5 into 1.5 equals to 0.75 plus, this is going to be minus 0.75 because this is minus. This is also going to be minus 0.75. It's the same. And this is going to be minus minus plus 2.5 into 1.5. So 2.5 into 1.5, and this is also going, this is going to be 3.75. Okay, so this is going to be, so this is going to be 1 by 4. 0.5 is half. Half square is 1 by 4. Half square is 1 by 4. So 1 by 4 plus 1 by 4 is going to be, so 0.25. 1 by 4 is 0.25 plus 0.25. So this is going to be 0.5 plus 2.5 is 5 by 2. So 25 by 4. So this is going to be 2.5 whole squared. So 6.75. So this is going to be 6.75 square root of, this is going to be 1.5 squared is 2.25. 1.5 square is 2.25 minus 1.25. 1.5 square is also 2.25. So this is 2.25 plus 2.25 plus 2.25. It's 2.25 into 3, 6.75. That means square root would cancel, and we will get only 6.75, and upstairs we'll get 3.75 minus 0.75 minus 0.75. So 2.25. So 2.25. So 2.25 divided by 6.75. That becomes 0.33 or 1 by 3. This is 1 by 3. Therefore, cos theta is 1 by 3. Theta is cos inverse of 1 by 3. This is a rather long calculation. Cos theta, cos inverse of this, and this is going to be 70.5 degree. 70.5 degree. One more thing is left. In question number B, there was another part where we had to find the area of the rectangle. So area of the rectangle is length into breadth. Let me do it over here. So length into breadth. So length of OA is going to be, OA is going to be square root of 2 square plus 2 square plus 1 square. That turns out to be 4 plus 4 8, 8 plus 1 9, which is 3. And OB is going to be, square root of 1 square plus 1 square plus minus 4 square. So it is going to be 16, 17, 18, square root of 18. Therefore, area of the rectangle is length into breadth, 3 into square root of 18.